Ever wondered why you often see astronauts bathed in a strange red glow inside their spacecraft? It's not for a sci-fi movie effect. There's a fascinating and vital reason behind this choice of lighting, and it's all about keeping our space explorers safe and sane. Stick around as we uncover the secret science of red light in space. Living on the International Space Station means you orbit the Earth every 90 minutes. That's 16 sunrises and 16 sunsets every single day. Imagine trying to get a good night's sleep with that kind of schedule. Your body's internal clock, your circadian rhythm, would be completely thrown off. This isn't just about feeling a little groggy. It can lead to serious health problems, decreased cognitive function, and a higher risk of making a critical mistake. And in the unforgiving environment of space, a small mistake can have catastrophic consequences. On Earth, our bodies are finely tuned to the 24-hour cycle of day and night. Sunlight, particularly the blue light it contains, signals our brains to be awake and alert. As the sun sets and blue light fades, our brains start producing a hormone called melatonin. Melatonin is the key that unlocks sleep, telling our body it's time to rest and repair. The problem is, standard white artificial lights, like the ones in your home or office, are packed with blue light. If an astronaut needs to get up in the middle of their night cycle, flipping on a regular light would be like a blast of morning sun. It would instantly halt melatonin production, making it incredibly difficult to fall back asleep and disrupting their entire sleep schedule. This is where the genius of red light comes into play. Our eyes have two main types of photoreceptor cells, cones and rods. Cones are for seeing color and detail in bright light, while rods are for vision in low light conditions. Rods contain a pigment called rhodopsin, which is extremely sensitive to light. When exposed to bright white or blue light, rhodopsin breaks down, and it can take up to 30 minutes for our eyes to fully adapt back to the dark. This is why you feel temporarily blinded when you turn on a bright light in the middle of the night. However, rhodopsin is much less sensitive to long wavelength light, like red light. This means an astronaut can use red light to see what they're doing without completely ruining their night vision. They can navigate the cabin, check instruments, or even use the restroom, and their eyes will remain adapted to the darkness. This allows them to quickly fall back asleep without that jarring, "wake up" signal that blue light sends to the brain. So how does this all connect back to sleep and that crazy 16 sunrise day? By carefully controlling the light spectrum inside the station. During their designated daytime, astronauts are exposed to bright blue-enriched white light. This promotes alertness, boosts mood, and keeps their circadian rhythms anchored. As their night approaches, the lighting system transitions. The blue light is filtered out, and the environment shifts to dimmer, warmer tones, eventually leading to the deep red used for nighttime operations. This gentle transition mimics a natural sunset, signaling the body to start producing melatonin and prepare for sleep. This practice, known as light hygiene, is crucial. It helps synchronize the astronauts' internal clocks to the mission's work-rest schedule, not the chaotic cycle of sunrises outside the window. This ensures they get the restorative sleep they need to perform complex tasks, conduct scientific experiments, and maintain their physical and mental health during long-duration missions. Without this carefully managed lighting, astronauts would suffer from chronic sleep deprivation, leading to fatigue, irritability, and a significant decline in performance. Now, imagine a critical situation. An alarm blares in the middle of the station's sleep cycle. There's a potential emergency, maybe a pressure leak or a system malfunction. The astronauts need to wake up instantly, be fully alert, and address the problem immediately. Thanks to the red light, they haven't been in complete darkness. Their eyes are already partially adapted. They can see their surroundings and move to their stations without stumbling around, waiting for their eyes to adjust. Once the situation is assessed, they can switch to full-spectrum white light to get the maximum alertness boost from the blue wavelengths, allowing them to tackle the emergency with peak cognitive function. Once the issue is resolved, they can switch back to red light, helping their bodies calm down and making it easier to return to sleep. This seamless transition between rest and high alert is a perfect example of how red light isn't just about comfort. It's a critical safety tool that enhances an astronaut's ability to respond effectively in a crisis. It preserves their night vision while gently guiding their sleep-wake cycle, providing the best of both worlds. So to sum it all up, that red glow you see in photos from space is a sophisticated piece of bioengineering. It's not just for mood lighting. First, it preserves the astronauts' night vision, allowing them to see in the dark without the long, disorienting adjustment period caused by white light. This is crucial for both routine nighttime tasks and emergency responses. Second, and most importantly, it protects their circadian rhythm. By avoiding stimulating blue light during their sleep period, red light allows for the natural production of melatonin, ensuring they get the deep, restorative sleep necessary for health and peak performance. It helps them stay on a consistent schedule despite the 16 sunrises and sunsets they experience every single day. It's a simple, elegant solution to a complex biological problem, ensuring our explorers in the final frontier stay sharp, healthy, and safe. The use of red light is a perfect example of how much thought goes into every single detail of space travel. It shows how we use science to help the human body adapt to an environment it was never meant to inhabit. What other cool space technologies or astronaut life hacks have you heard about? Let me know down in the comments below. And if you enjoyed this deep dive into the science of space travel, make sure to hit that subscribe button and ring the bell so you don't miss our next adventure. Thanks for watching.